Hello and welcome to the build along video tutorial for the Harmonic Percolator. So we're going to be building along with this cult classic and talking about it and maybe get some ideas for some modifications and a little education, and let's get started. Alright, so just like any other project that we're doing here, we got to get our power rails distributed first with some wire. So let's do that. You guys are already pros at it, I know, but we got to do it. So we're going to be using the same wire for everything here. Just going to make it a little bit faster. If you guys need to do it by color, you can always purchase stuff from us or online. But I think you guys already know that it's not going to matter color-wise, as long as the connections are made. So, alright, so now we've got power, and we've got ground distributed through our pin headers here. You guys are already pros at this. Alright, so we're going to be going with step one, the usual culprit. We're going to need our shunt diode. We're going to need capacitor for blocking a little bit of noise from our power lines, and we're going to assemble those. This time we're going to assemble them actually in the bottom rail as opposed to the top rail, and we're going to talk about that in just a sec. So we're going to quickly touch base about the power rails here I was just mentioning. We're going to be putting our DC filtering and shunt diodes in the bottom rail because that's actually where our 9 volts is going to be fed, and we'll probably elaborate on that a little bit more shortly. But let's start here with our diode. Let's bend this guy over, just like I've explained before for you guys. I like to snip them a little bit shorter. Really makes it sit into the breadboard a little better. We're going to be placing this guy here. You can really place it wherever as long as it is the correct orientation. And remember that this is a shunt diode. This is essentially if you get the wrong power. So we're actually going to have our negative lead in the hot rail. Seems counterintuitive, but in this orientation it's actually what we want. Next we're going to grab our big 100U, and remember we're going to look for our negative band or our short lead. So much like the others, we're going to snip those down to make it even. We are going to remember to have the negative lead in the ground blue rail. And then lastly, we're going to grab our 47N. You could also see it read as 473. That simply means that there are 3 zeros after the 47. You guys can find all this information in the manuals, and you're already pros. So, alright, let's throw the last capacitor here, and there we go. We've got step one done. We've got our diode, we've got our 2 capacitors, and now our power rail has got a little bit of conditioning, and we're going to be ready to go on to step 2. Alright, so next we're going to go on to our input stage. This is going to be step 2. This is going to be different than we've actually done in other kits because we're actually going to have an input potentiometer here. So we're going to need our potentiometer. We got a 100 pico and we have a 47N capacitor. We're also going to need some wire for this, our good old friend wire. So we're going to jump out of our input into the playing grounds. We're going to get a little bit farther away from the input here, just so we have some room to play. And we're actually going to hit our harmonics potentiometer first. You guys can see this in the schematic. This is an A100K. This is essentially going to decide how much signal is going to be let in. So you can kind of think of it as this circuit is kind of got two knobs, your input and your output amount. Alright, so we're going to leg 3. Remember, we've got our pot says 1, 2, 3. So our input is going to 3, and then 2 is going to be our output. Now before we go to pot leg number 2, which is our wiper, we actually have to ground pin 1. So I'm going to grab a little bit of jumper wire, like that. Stay kind of clean. Then I'm going to jump just like that. Alright, so now you see we've got our input to 3, our ground to 1, our wipers is number 2, and that's going to just kind of be a blend between the two. Are we getting to the right and it's all guitar, to the left and it's going to be grounded out, so it's muted? That's up to you, how much you want at the input. Alright, so next for this build, we typically stay over on this side for a lot of it, but we're actually jumping right over here because we're going to be doing our business, a lot of it down on the bottom rail. So let's jump this channel here, a little bit of wire, bend this guy over. Alright, great. So now we're going to actually get to our first actual component that isn't a potentiometer here, and we're going to get to our 100 pico little ceramic cap, the little brown guy like this. So this guy has to find its pathway to ground. So the legs are very short, so it's got a short pitch, so all we're going to be doing is placing it on the same line as this wire here, one row over. We're going to take a second piece of wire, bend it like we always do, and now we'll be able to find ground there. So this is just going to add a little bit of roll-off for uber high frequencies in the circuit. You can also feel free to mess around with this, just like pretty much any part in one of these builds. Okay, so now we've done that. We've got our roll-off for really high frequencies in the treble range. We got to get to C4, which is our input coupling capacitor. You guys know that that's going to allow AC to pass, but it's going to block DC. So we got to jump over from where we were. Just like that, so that we can kind of get out here into the open. And our last part in this step, we got another 47N. Simply placed right there. And now, yeah, we've run around a lot, but this is actually going to give us a lot of space, which is really nice if you like to modify stuff or maybe add extensions to things like certain filters or needing just some room for parts to add on in the future. Plus it just kind of helps you see and kind of dissect what's going on when you haven't been at it for a while. This is kind of like a treasure map, and you got to be able to read it. If it's cleaner, it's going to help you a lot more. Alright, so that is it for our input stage, and next we're going to be going to our first amplifier stage. So here we are, step 3. We are at our first amplifier stage. This is going to be our PNP stage, which is actually something that's somewhat new. Only the Octafuzz has had a PNP transistor. We're not going to really get into the weeds on PNP and NPN. You guys can do some work on your own, a little bit of research. You can find some circuits that have it. We are not really going to get too far into that now, but really this circuit, the way it's working with the two stages, has got this cool like push-pull thing going on. That's, you know, essentially they're going to be making even order harmonics, which is really cool, very satisfying to the ear. But I'll let you guys do some reading on your own as well let's set up our first stage around the PNP transistor. We got a 3906 for this one, and we gotta essentially get away from our input stage a little bit. So we're going to go about there. Now the nice thing with the 3906, just like the 3904 and other NPNs, this one has the same pinout. So we've got emitter, base, collector, EBC, just like normal. Now, how it's doing stuff here is kind of flipped versus the NPN, but nice thing is the pinouts are there. Remember, when in doubt, the internet's going to be your best friend here. For type the model and then write the word pinout in the search bar, and you're going to be able to match a couple images. So, all right, let's get back to it. We have to get over to the base. So we got to get over from our input to the base of this transistor, which is the dead middle. So the middle leg base is going to be connecting to the inside of our input coupling capacitor. Now we're over to the base, and that's exactly where we want to be. Okay, so next, let's do the harder part of this, because we kind of have to make this biasing feedback loop here with R3. So we need to find our 220K. That's this guy here. Make sure you guys use your color chart. Essentially we got a red, red, black, orange, brown. But because this guy is in the feedback loop and going only one pin with a long bodied resistor can be a bit cumbersome. You could do the tombstone thing where you're going to stand it up so that it can go simply row to row without having to jump. But to keep it cleaner and to audition stuff with like our sub boxes and whatnot, it's going to be a lot easier to kind of actually spread it out. So what we're going to do, we have to go from the base to the collector of this Q1. So what we've done here is we're actually going to be going out and occupying the channel, or the other side of the channel, I should say. So we've got our resistor, we're bending this over a little bit, as we always do. Cutting a little bit of this off the legs. Now we have to come back across the channel. So this wire jump a little bit shorter. There we go. Now the last thing, we got to get to the collector. Remember, emitter, base, collector, EBC. So to get over there, one last piece of wire, and you'll see I'm using greenies to kind of stabilize it and really place that component lead in. Helps me, might help you. Okay, so there we go. We have a very elaborate feedback loop and a biasing for this transistor stage. It's also going to come in play in the next stage, which we'll talk about after we finish this one up. So we need our R4 resistor. This is going to be a 12K. This guy's going to be dumping directly to ground. So we're going to actually be able to come off of the collector that we just did the loop to. And we're going to go see, we got emitter, base, collector. Let's move this a little bit. Alright, so input here is going to the middle, which is our base. that slip here. We gotta go out of the base here. I'm sure you guys caught that, you just didn't tell me. Alright, let's move this over a single row. There we go. Now we're going to be cooking. Now we've got an actual feedback loop. There we go. Now we're cooking. So we got our input going right to the base. The base is going to go over the channel to this 220K. It's going to come back across and go into the collector. That collector is then also dumping this 12K directly to ground. So now all we've got left is C6, which is a 47U, and that's actually going to set the gain of the amplifier stages together. So we've got our 47U. Remember, we got it polarized here. We are going to want to find the short or the negative strip. And we're going to cut a little bit off of it like this. We're going to extend our legs out just a little bit so that we can jump over to our power rail. We're going out of the emitter, which is our left leg, so keeping the orientation and the polarity correct. That's what we want. So there we have it. It's going to help keep it nice and clean, so you're going to be able to see it, but everything here is in step 3 finished. And next, let's head over to our second amplifier stage for step number 4. Alright, we got the first half done of our amplifier stage. Next, we're going to go on to the we're going to go to the NPN step of our amp stages. For this step, we're going to need our NPN transistor. For this build, we're using the 2N5088, very common transistor. We're also going to be using a couple resistors, and we're going to be using a film cap as well. So, where we last left our build, we were at Q1. What we're going to have to do is we got to get out of Q1. We're going to jump into the second transistor stage. So let's part these legs a little bit. Now for this, we got the flat side here, right? And we've got emitter base collector. That's the left. Emitter base collector, left to right. We're actually going to flip this around and have the flat side away from us for this build, just because it's going to be a little cleaner. So we are going to place this transistor right about here. Okay. So we're gonna get our next step, which is going out of the first transistor into the second one. And it's actually where we're gonna be, both the emitters are gonna be coming together. This is kind of a unique part of it. But the emitter, the reason I flipped this one with the flat side away from us and this first one with the flat side towards us is that now the emitters are facing each other. So what we can do now is simply connect them. Piece of wire here, piece of wire there. And now, there we go, we have our emitters collected to each other. Alright, so we need to get some voltage to this transistor, and we're going to be doing that through a 100K with an 820K in the feedback and setting the bias for the base. So let's find our 100K. Here we are. Let's actually put this aside. Let's do the 820 first because it's going to help keep our breadboard nice and clean. So, as usual, cut that. We're going out of the base. couple rows, just like that. Remember, the base is our middle leg. We're going out a couple rows, and we're going to go back to this 100K I was talking about, because we got to get this over to our collector. So here's a fun way to do it. We're going to go out of our power rail, just like that. So we got power here. We're meeting up with this leg, and this 820 is going over to the base. But if you look at the schematic, we still have to get this leg over to the collector without any interruption from another resistor. So the way that we're going to do that is like this. Piece of jumper wire from this row over to the collector. Remember, from this side we got emitter, base, collector. So we've connected our 100K to the collector through this black wire, and then we've got our base biasing here in the feedback loop 100K through the 820K right to the base. Now all we have left to do is a really interesting part in this circuit, where we've got C5, which is going to be a 0.1U. This one is kind of adjusting like the bass frequencies for this circuit. What we got to do is we actually have to get the bass here to talk to the collector over here. Now remember, we've got our collector right there, so you guys can probably guess that's what we're going to do. Let's grab some more wire. We're going to jump this rail first. We're going to jump over the channel from the base. Base is in the middle. Jump over the channel like this. Grab our 0.1U. Great. Now we have to get to this piece of wire here, because that's going to meet up with our collector. So we're going to jump around this way. Then with one last piece of wire, connect to that 0.1U that we had coming out of the base of Q2. There we are. So now we've got the base of Q2 going through that 0.1, through this wire, through this wire section, back to the collector. So essentially from this base to that collector, it's a long way, but it keeps it clean, and it's going to have that cap with a direct path to it. So that's actually going to conclude our NPN amp stage, and we're almost at the home stretch, and next we're going to go into our output stage and do a little bit of clipping and kind of talk about that section next. Alright, so here we are. We're at the home stretch. We're going to get into step 5, and in this step we are going to be doing a little bit of output clipping and EQing before our master output. So in this step we're going to need our output potentiometer, a couple diodes, a couple capacitors, and a single resistor. Alright, so where we left off was at the output of our second stage that we just finished. So we're actually going to tie right into here. We're going to grab a 0.1 cap. Now we've got 2 in this step. We're going to need a 0.1, not the 1N. So let's take a look here. Alright, so our 104, that's our 0.1, and this is our 1N. You can always refer to the build guides for how to read these capacitors. So we're going to tie off right where we left off at the output of the last stage. So that's going to be our output coupling capacitor. And from there, we're actually going to jump over the channel to round off a lot of this circuit. So we need a little bit of wire. Quick little bend, and we're going to jump over the channel, just like that. And now here's where we need to get the other capacitor that we didn't choose. I actually grabbed the wrong cap for that, James. I'm going to just start again. Okay. Alright, back to the beginning of step 5. Alright, so we are at the final stage. We're at the home stretch. We are going to go on to step 5. This is going to be our output and our clipping stage. Plus we're going to be doing a little bit of filtering. So we need 2 film caps, we need a resistor, a couple of our diodes, and we need our output potentiometer. Alright, so in this step we are going to be doing a bit of clipping. We're going to talk about that. We're going to be doing a little bit of filtering, and we're going to get to the output. So where we last left off was right here on our breadboard. Let's put this back here. Alright, so here's the output where we left off. What we want to do is we want to find our output capacitor. That's C6. It's a 0.1 U. Let's take a look. These are both similar. So let's remember how we read them. First 2 are at face value, and the third is how many zeros. So we want to go with our 102 for our EQ. So we're going to grab this 104. This is going to be our output capacitor for C6. So this 104 is going to tie off right where we left off at Q2. And what we want to do next is actually grab a little bit of wire and jump the channel to round off most of the circuit. Alright, so we're going to make a simple jump right there. And now we're going to grab that other capacitor that we weren't using for the output, because we're going to use this guy for a little bit of EQ. So we need to get this guy to ground. Fastest way to do that is jump over a couple rows and then simply jump to the ground rail. Alright. So that's going to look something like this. So, when I was working on this circuit for this club, the harmonic percolator is kind of new as a circuit for me. As we mentioned at the beginning, it's kind of like a cult classic that a lot of people admire. I found that there was a little bit of a shrillness kind of on the higher end, and I want to tame that, so you're going to see that this actually isn't in the original schematic for even a different value. It just doesn't exist there. I want to take a little bit off of the top without taking away from the essence of it. So that's what we're going to be doing there with C7 going to ground. It's going to take off like the really higher top end there. Alright, so we got to get to the clipping, everybody's favorite part. We're going to jump a little bit away from that filter cap. Jump over one rail, and now what we're going to do is we're going to have a little bit of space to breathe to do our clipping. So we're using BAT 41s in this build. We're going to snip them as usual, and we've got to get them to ground. The first one is going to be, as we normally do with it, it's going straight to ground in our output signal path. Now D2, we want to have the positive, or the anode, or the non-striped part going to the ground source. So we're going to orient it something like this, with the stripe staying inward into the signal path and the positive going to ground. So now here's where it gets kind of cool from a clipping standpoint. As you see R5 and D3 as the second clipping diode, there's actually a resistor that's between the signal and the diode to ground. So this is kind of cool. It does a little bit of filtering in conjunction with C6 to do a CR filter. Plus it softens the edge a little bit there too. It's kind of an interesting way to do it, which is really smart of the way that they're implementing it. Going through this resistor here, it doesn't turn on as fast as the diode that's going directly to ground, so it kind of behaves a little different. It doesn't turn on right away, and it softens it a little bit, which is cool. So you can kind of mess with that as well to really flavor it your way. Alright, so we've got R5 in, we jumped over the channel, now we've got our last diode to do, and remember, the band is going to be our negative, and on this one we want the negative going to ground. So we are going to place that right there. So there we go. If this black wire here is our audio signal, we've got the positive going to ground there, and then the negative going to ground here through this resistor. So all we got to do now is get to our output potentiometer and then to the output. So we are going to throw our potentiometer right about there. I'm going to grab a little bit more wire, and we're actually going to kind of mirror what we did at the input. And you can actually see how we're mirroring the input. Let's grab a little bit more wire. Alright, so let's remember the input is essentially a blend here. Our lug 2, or our wiper, is a blend of ground and the input source. Here we're going to have a blend of the output of the signal and ground, and 2 is still going to be our blend, if you will. So before we go to the lug 2, let's jump over to lug 1. We have to ground that. So we're going to jump over a little bit, some wire, and we're going to jump to our ground rail. There we go. So now, just like the first step, we've got lug 1 grounded. Now all we got to do is get to the output, and this will allow a blend of circuit or ground, and that'll determine how loud we are. So it's essentially an output attenuation. Pretty standard configuration. There we go, one more piece of wire and we are home free. Alright, there we are. That is the Harmonic Percolator, a very unique even order harmonic, PNP, NPN, double transistor, interesting clipping section made famous by the likes of Steve Albini, his work with shellac, and a lot of others. Hopefully you learned something here, had fun building it. Maybe you're going to modify it for yourself. And yeah, we appreciate you being here with us and following along, and we'll catch you on our next one. Thanks so much.